You can see here the question, a train of weight 1870 kilonewton without the locomotive starts to move with constant acceleration along a straight horizontal track. Clear? So that particular train without the engine, actually it is moving with constant acceleration along a straight horizontal track, and in the first 60 seconds how much velocity it is acquiring? 56 kilometer per hour. Okay, so determine the tension in the drawbar between the locomotive and train if the total resistance to motion due to friction and air resistance is constant and equal to 0.005 times the weight of the train. Already the weight of the train is given how much? Somebody should answer. 1870 kilonewton. Is this clear? The question is clear to you?
Yes, sir.
What is the weight of the train?
Weight of the train is 58
What is the weight of the train? 1870
$1,870 kilonewton.
kilonewton.
kilonewton. Suppose you are not able to take down the notes, I am already recording this particular class. Okay, don't worry about it. Try to understand the problem. I'll share the link to you. Okay, then you can note it down whenever you're free. Okay. Next is the weight of the train is 1870 kilonewton. In the first 60 seconds, what is the velocity of the train?
56
56
56
kilometer
kilometer
per
per
kilometer
hour.
per
hour.
hour.
So here our main idea is to find out what is the tension and how are we designating the tension? That is capital T. Clear? So we have to find out what you have to find out. We have to find out what is the tension T in the drawbar. What is drawbar actually? Drawbar is actually the connection between the train. Clear? Or you can say the train bogies. Okay. So when the train is running, maybe towards it is running in which track? Horizontal track. So the train can, you assume that the train is running towards right side or towards left side. So during when it is running towards right side, if we assume that it is running towards right side, so there is an air resistance and a frictional force. How much frictional force and air resistance is there? 0.005 times the weight of the train. Okay. So
Yes,
shall
sir.
we solve the problem? The question is clear to you, all of you?
Yes,
Sir.
sir.
Okay. So now can you see the white screen here?
Yes, sir.
Okay. Now just try to remember the question here. I'm going to draw the diagram for that. Clear? So here you can see we will consider this as a particular train. Now this particular train is running on what?
Uh, railway.
On a horizontal track. Okay. So assume that this is the train, and here there is that particular thing which we call it as what? Drawbar. And what is actually this? This is the drawbar. So in this drawbar, you assume that this is accelerating in this particular direction with an acceleration of a, and this T you have to find it out. So T is the tension in the drawback. Is this clear? Now weight always acts vertically downward. What is the weight of the body? The weight of the train? 1870
1870 kilonewton.
kilo Newton. Okay. I hope it is visible to you, all of you.
Yes, sir.
Now this
Yes, sir.
train actually it is actually moving towards, we have assumed that it is moving towards which side? It is moving towards the right side. Clear? So how much now? After how many seconds it is acquiring a velocity of 56 kilometer per hour? We have seen. After how many seconds? Yes, after how many seconds it is acquiring a velocity of 56 kilometer per hour? Yes, after
66.
60 seconds. How much velocity?
After 60 seconds.
Yeah, it is acquiring
56 kilometers per hour.
yeah 56 kilometer per hour. So what we do here is that 56 kilometer per hour is actually what? It is the final velocity, you say it. Now here, what is the initial velocity? What is the
0.
what is the initial velocity? Initial velocity is
Initial velocity 0.
0. Okay. Next, what is the weight of the train? So weight of the train is W, which is 1870 kilonewton.
70 kilonewton. Yes, sir.
Okay. Next is the final velocity. The final velocity of the train. Now the final velocity of the train actually it is given in kilometer per hour. 56
Yes, sir.
kilometer per hour. Let us change it into SI unit. That is 56 kilo. 1 kilometer is 1000 meter. You know this. And 1 hour is 3600 seconds. Is this clear?
Yes, sir.
All of you.
Yes, sir.
Yes,
Yes,
sir.
Now
sir.
what we do is you don't have calculators, so you can see the calculator here, all of you. Is it visible?
Yes, sir.
Yes,
Okay.
sir.
So as I told you, always I say in the class, let us check whether it is in degree format or not. Yes, it is in degree format. Clear? So it is 56 into 1000 divided by 3600. How much you got? 15.55. So it is 15 point.
15.55.
Okay, we'll round it off and we'll take 15.56 meter per second. Did you get this? So this is the final velocity of the train. So that particular final velocity of the train, let us represent it in the diagram. Okay. And this particular velocity, after how many seconds that particular train is acquiring? After how many seconds?
60.
60 seconds. So the total time, T is actually 60 seconds. Okay. So this is all the given data. What is the other given data? Total total resistance. Total resistance due to friction, as well as you can say due to friction, or you can say that is the air resistance. Okay. So due to air resistance, already it has been said here, you see here 0.005 times the weight of the train. Okay. So it is 0.005 times the weight of the train. Okay. So let us calculate how much it is. So 0.005 multiplied by the weight of the train. The weight of the train is how much? 1870 kilonewton. Okay. So again, let us go to this calculator.
9.35.
Okay.
9.35. 9.35.
9.35.
Okay. Thank you. It is how much?
9.35.
9.35. What is the unit? Kilonewton. 9.35 kilonewton. Okay. So basically, what you have to find out, what is the tension in the drawbar. So T is nothing but the tension in the drawbar, which you are going to find it out. Okay. Now let us go to this particular diagram. So this resistance, because the body is accelerating in this particular direction towards right side, so the frictional force will be towards which side? The frictional force will be towards left side.
Left side.
Opposite, yeah, opposite side. Okay. So that is 0.005 times the weight. So how much you got? 9.35 kilo
3.
kilonewton. So this completes your total diagram. Now you say, by seeing this particular diagram, the body is actually moving in which direction? Towards the right side. Okay. Frictional force is towards left side. Now, now you know the equation of motion is, what is the equation of motion? The equation of motion is, applying equation of motion. Equation of motion, as already said, that summation of F is equal to W by G into A. So which force is actually responsible for the motion of the body? Can anyone say? So here, which force is responsible for the motion of the body? The body is going in towards right side or
So
no?
T.
Yeah, T minus,
Yes, sir.
T minus how much?
T minus
S.
F.
9 point, yeah, 9.35.
9.05.
Is this clear? So that is the force which is responsible
ठीक
for
है.
the motion of the body. T minus 9.35 as seen in the diagram. I hope all of you understood. Now what is the weight here? Weight is how much?
Weight is
One, one,
187.
yeah, 1870.
1870.
Okay, by 9.81
9.81
into
into acceleration.
acceleration. Okay, so here in this particular
Yes, sir.
equation you have actually two unknowns. One is your T and the other is your A. Okay,
Acceleration.
acceleration. So let us find out what is the acceleration. Substitute in this equation, you will get T. So how to find acceleration? To find acceleration, clear. So you have certain data which already I have written, that is initial velocity is equal to 0 and final velocity is 15.56 meter per second and the time is how many seconds? 60 seconds. So which equation you are going to use now to find out A?
V equal to U plus AT.
Good. V is equal to U plus AT. So from here, A will be V minus U by T. So 15.56 minus 0 by 60. How much you are getting? 15.56 by 60. What is the value?
0.25.
0.251.
0.25. What is the next value?
9.
Okay, so I'll take 0.26, round it up. Okay, is this clear? Now substitute the value of A in this particular equation to find out what is T. Now, so finally, I'll write T is equal to, can I write like this? 1870 by 9.81 into 0.26 plus 9.35. Is it correct? What is the answer you are getting? Okay, 1870 divided by 9.81 into
58.91.
0.26. It is how much? 58.91.
58.91.
58.91.
What is the unit? What is the unit? Kilonewton.
Kilonewton.
Okay. So this is how we solve the problem of this equation of motion. I hope it is clear to you, all of you.
Yes, sir.
Okay. So don't worry if you have not noted it down, you can note it down afterwards. Is this clear? Now let us
Yes,
go
sir.
to the next question. Is it visible to you?
Yes, sir.
Yes. Can anyone read
Yes,
the
sir.
question?
Yes, sir.
Anyone?
a driver and automobile traveling along a straight level highway suddenly suddenly applies the brake, so the car car slide for 2 seconds, covering the distance 9.66 meter before coming to the stop. Assuming that during that is the time the car moved without constant direction, and the conflict of friction between the trees and pavement.
The question is the driver of an automobile traveling along a straight level highway. So okay, automobile, it can be a car or it can be a bike, anything. So he is going on a road and the road is it is a straight level road. So he's suddenly applying the brake. And you all know that when a sudden application of brakes is taking place, the car is sliding for how many seconds? The car slides for 2 seconds. Okay. So whenever you are applying the brakes, deceleration will take place. What is the deceleration, anyone? Deceleration is nothing but it is negative acceleration. Okay.
Negative,
Negative
yes, sir.
acceleration,
Yeah, you
yes
can
sir.
say retardation also. Now, the car is sliding for how many seconds? It is sliding for 2 seconds. And how much distance it is actually covering during that sliding? It is sliding for how much distance? 9.66 meter distance it is covering. Clear? So, in 2 seconds it is covering 9.66 meter, and finally it is coming to stop. Stop, when it is coming to stop, what is the final velocity? What is the final velocity?
Zero, zero.
The final velocity is 0. Is this clear? So, you assume that during this time the car is moving with constant deceleration. What actually you have to find out here? You have to find out what is the coefficient of friction between the tire and the pavement. Pavement means it is a road actually we are talking about, the car which is traveling on a straight level road. Clear? So, this is the question. Again, by reading the question, you have to draw the diagram. So, important parameters you just try to remember. The time is 2 seconds and it is traveling a distance of 9.66 meter, and finally it is coming to stop, and it is moving with constant deceleration, that is negative acceleration, and you have to find out what is the coefficient of friction. Clear? I think this is visible to you, all of you, the white screen. Yes?
Yes, sir. Yes, sir.
Now let us draw the diagram. Again, you always draw the diagram in a very simple way. So let us assume that this is a car as given in the question. Clear? The weight of the car is not given to you. Is it given to you, the weight of the car? Weight of the car
No sir.
is not given.
It,
Clear?
it is
So
not
don't
given.
worry about it. So the weight of the car is not given to you. Clear? So this is the car and these are the tires which is actually running on a straight level road. Clear? So here also, with which acceleration? It is deaccelerating or not? So deacceleration means negative acceleration. How much? Negative acceleration. Okay. So finally when it is coming to stop, so finally it is stopping at this particular point. Finally when it is stopping, how much distance it is traveling? Anyone?
2 meters.
See, all of you try to understand the question. Here you see the car is
Time
coming
period is 2
from,
seconds.
9.66.
yeah, the car is coming from somewhere else. Okay. After reaching this particular point, which you can see here where my pen is located, so here he started applying the brakes. When he started applying the brakes, the car is slipping or skidding for 2 seconds. from this position to this is the final position. Okay, so during these 2 seconds, how much distance it has traveled? 9.66
6.
meter. In how many seconds?
2 seconds.
In 2 seconds. Okay, so now ultimately between the tire and the pavement, between the tire and the road, there will be a friction or not? There will be a friction or not?
Yes, sir.
Yes. So in which direction? Because the car is slipping in this direction, so in the opposite direction friction will be there. And all of you know frictional force is equal to mu into
And
n. Now the weight is acting vertically downward, and this will be the normal reaction or not, all of you?
yes, sir.
Is it correct? Now from this
Yes, sir.
diagram, n is equal to w or not? You see there are only two vertical forces.
Yes, sir.
Okay, during the total journey, n will be equal to w or not?
Yes, sir.
During the total motion. Okay, so here can I write mu into w?
Yes,
mu
sir.
F equal
F is equal to
to
mu n is equal to w. So I have substituted instead of n, I have substituted w. Okay,
yes sir.
is this clear? So here you have to find out, the question is what is the coefficient of friction between the tire and the pavement. Clear? So let us see here what is the given data. What is the given data here? So t is how much? T is 2 seconds. S is how much? 9.66
9.6.
9.66.
meter. What is
9.6
the final velocity? Before coming to stop,
0.
finally the car is stopping here. Always try to draw the diagrams
Yes
in
sir.
the examination in this way, where the total data is reflecting in this particular diagram. Okay, so
Yes sir.
final velocity is 0. So what you have to find out? You have to find out what is the coefficient of friction between the tire and the pavement. Okay, so now what you do here? What we'll do? Using again equation of motion, same thing. Using equation of motion. What is equation of motion? Summation of F is equal to W by G into A. Now by seeing this diagram, which force is responsible to finally stop the body? Which force?
Frictional
F.
force.
Which force? You can see here.
Frictional force.
Yes. Frictional force or not? Very good.
Yes,
So in
Yes sir.
horizontal you can see only one force is there. When when at this particular point, you are applying the brakes, frictional force is applied. Due to frictional force only, finally the car is stopping here, and finally the velocity becomes 0 and it comes to rest. So which force is responsible for the body to stop? That is frictional force. So what is frictional force? Mu into
mu W.
W. Again, W by G, yeah, W by G
9.81
into A.
minus N.
Okay, is this clear? Hey, why minus A? Somebody said minus A. Why? How it will be minus A?
The retardation.
Okay, you see here. No doubt this is retarding and finally coming to here you can see. No doubt, this is finally retardation, deceleration is taking place. Finally, it is coming to what? The velocity is coming to zero or not?
Yes, sir.
But the frictional force is in which direction? It is in the
Opposite.
opposite direction of acceleration or not?
Yes, sir.
If you want to take this direction as what? This direction, if you want to take as minus a, if you want, you can take it. Then this will be which? This will be negative or not? Are you getting my point? If this is
Yes,
positive,
yes, yes.
yeah. You see, if this is positive, what is the what is the value of acceleration minus a or not? So this will be negative or not?
Yes, sir.
So what I'm doing here is the acceleration direction I'm changing. Can I change the direction and can I put it as a?
Yes, sir.
Why
Yes,
why
sir.
I- why I have done is because both I am taking as positive here. You can see both I am taking as positive, so both should be in same direction. Now is it clear why it is a? All of you?
Yes, sir.
Yeah.
Yes, sir.
So in this equation, W and W gets cancelled because W is not given to you. Okay. So finally, you have to find out what is mu. What is finally mu is equal to A by G.
A by G. Yes, sir.
Okay.
Uh,
But let us find out.
acceleration.
Yes. Let us find out what is acceleration by this particular
Yes,
data
sir.
which is given to you. Which equation you are going to use? S is equal to
H is equal to 9.6
ut
UT
plus
T
plus
plus
half 80
half
square.
80 square.
Yes, sir.
Okay. S is equal to ut plus half 80 square. Okay.
Mm,
Now,
yes, sir.
so S is equal to
9.66.
we don't have U. Do you have U here?
No, sir. You does not think
You don't have U. So for that, what you do is I'll take one more equation. V is equal to
U plus 80.
U plus 80. This is negative acceleration or not?
Yes, sir.
So V is equal to U minus
80.
80. What is the final velocity?
0.
0. So finally you will get U is equal to 80 or not?
Yes, sir.
You will get U is equal to 80.
80.
This U is equal to 80, you substitute here. Sir, why we are substituting here? Because we do not have the value of the initial velocity. Clear? So what we do is, without wasting any time, let us substitute what is S here. S is equal to 9.66, okay, is equal to AT square,
80 square.
AT square minus half AT square. All of you are clear why it is minus? All of you are clear?
Yes, sir. Yes, sir.
Let me
Due to
write yeah
negative acceleration.
let me write one more equation. It is ut square, sorry, at square
Due to
plus half into minus a t square. That is the reason why it is minus. Okay, so at square minus half at square is how much? Half at square or not? Yes or no? At square minus half at square is
Yes, sir.
half at square.
yes, sir.
So from here let us find out what is a. So a is equal to 9.66 into t by into 2 in by t square. Okay, so let us calculate this, how much it is. 9.66 into 2,
It is hybrid.
okay, divided by how much?
4.83.
Yeah,
Ne-
4. 4.8.
4.83,
4.8.
yeah, meter per second square. Okay. Now you substitute the value of A here, 4.83 divided by 9.81. How much you're getting? How much? 0. 0.49. So it is 0.5. Round it off. Understood? All of you? Have you understood the problem?
Yes, sir.
Shall we go to the next problem? So this is the next question. Can anyone read? Can you see the question?
So a mine cage of weight W equal to 8.9 kilonewton starts from rest and move downward with constant acceleration, traveling a distance s 30 meter in 10 seconds. Find the tensile force in the cable during this time.
All of you know what is a mine case. Mine case means we are talking about uh, the elevator or the lift which mainly you find in the main mining area. I hope everybody has seen the mine cage. Most of in movies you might have seen. Clear? So it's a kind of lift which is actually existing in the mining area. What is the weight of the cage? What is the weight of the cage?
8.9 kilonewton.
8.9 kilonewton. Clear? So it is starting from rest.
Rest.
Okay. So what is the initial velocity?
Initial
0.
velocity 0.
Initial velocity is 0. Okay. It is moving in which direction? Downward.
Downward.
With what acceleration? Constant acceleration.
Constant acceleration.
How much distance it is traveling?
30 meter.
What is the in how many seconds?
Time, time period is 10 seconds.
10 seconds. Finally, what you have to find out? What is the
Force.
tensile force? Okay.
Tensile force. Sir.
Tensile force in the cable which is attached to the main cage. Okay. Clear? So mine cage is a kind of elevator. So by reading the question, let us draw the diagram. Okay. So is it visible? All of you? Is it visible to you?
Yes, sir.
Weight of the mine cage is always acting vertically downward. What is the weight? Weight is 8.99 kilonewton. Okay. So here to this particular mine cage, you have one cable which is attached to it. So which force will be there in the cable?
Tensile force.
Tensile force.
Tensile.
Yeah, it is going in which direction?
Downward.
Downward direction with an acceleration A. Okay, so let me draw. So it is a traveling in downward direction. Clear? Already I told you that from center to center, how much distance it is traveling in downward direction with a constant acceleration of a
30 meter.
30
30
meter.
meter.
30 meter.
How many seconds?
10
10 seconds.
10 seconds. So now one more data you can put it in this particular diagram. Okay, so main cage of weight 4.8.9 kilonewton. It is starting from rest. So what is the initial velocity?
0.
0.
Initial velocity is 0. Okay, so you have to find out what is
Zero.
you have to find out what is the tensile force in the cable. Okay, so after traveling 30 meters in 10 seconds, what is the final velocity that is not given to you? I hope the diagram is clear to you, all of you. So by reading the question, you have to draw the diagram in this particular way so that you can easily solve the question. Okay. Now, all the data are given to you. Clear? So let me write down here again. What is the given data? The given data is weight is 8.9 kilonewton. Initial velocity is 0. Distance covered is 30 meter. And in how much time it is covering a distance of 30 meter? That is 10 seconds. And you have to find out what is the tensile force that is acting in the cable. Same thing, just again you see this diagram. Which force is responsible for the motion of the body? And okay, before finding that, you should be very careful about in which direction the body is moving, or the that particular elevator is moving. The elevator is moving in which direction?
Vertical down.
Downward.
Downward direction.
Downward.
Okay, now you say applying the equation of motion, what is the net force? What is the force which is responsible for the motion of the body? Can anyone?
W minus T.
T. Very good. All of you are clear? There are two forces here. One is W, the other is T. So because it is going in downward direction, so the net force will be W minus T. Okay. So let us write that equation of motion. Okay. Summation of F is equal to W by G into A. So as already said, by seeing the diagram, which force is responsible for the downward movement of this particular cage? It is W minus T is equal to W by G into A. Is this clear? So what is T? T is equal to W minus W by G into A. Is it correct? Are they correct or not? Weight is given to you.
Yes, sir.
You know the value of acceleration due to gravity, but you do not know what is acceleration. To find out acceleration, again, which particular equation you are going to use? S is equal to ut plus half a t square. Because why I am using, how to know which linear equation has to be used? Clear? Because initial velocity is given, time is given, acceleration you have to find out, and the displacement is also given to you. Clear? So what is the displacement here? Displacement is 30 is equal to Because the
30.
initial velocity is 0, this particular u into t will be 0. I'm not going to write that. Half a t square. Okay. So a is equal to 2 into 30
0.6.
by t square. So 2 into 30 by 10 square. How much you're getting?
0.6
Okay, 0.6 meter per second square. Substitute this value of
seconds per.
A in this equation. You'll get what is the tension in the cable which is attached to the mining cage. So W is how much? 8.9 kilonewton. No need of changing into Newton. 8.9 by 9.81 multiplied by A you got as 0.6. So solve this, how much you're getting? Let me solve this. 8.9 divided by 9.81 into 0.6, that is 0.54. Okay, so 8.9 minus 0.54. How much you got? Yeah, 8.9 minus 0.54.
8.35.
8.35 kilonewton. So this is your answer. Is this clear? All of you?
Yes, sir.
Yes, sir.
So this is how you solve the problem. Okay. Shall we go to the next problem, last problem of equation of motion? I'll give you some assignments also.
Okay, sir.
Is it visible to you? And
Yes,
Yes,
sir.
sir.
yes, this problem is very, very important. Somebody read out the question. Anyone?
A weight W equals 4,450 kg is supported in a vertical plane by string and pulleys arranged as shown in the figure. If the free end A of the string is pulled vertically downward with constant acceleration A equals 18 meter per second square, find the tension in the string, neglect friction in the pulley.
Okay. So here the question is a weight W of, what is the weight here? 4,450. Okay. 4,450. Now that particular weight is supported in a which plane? It is supported in a vertical plane. Clear? And how it is supported? With the help of a string and with the help of a pulley, as shown in the diagram. I'll show you the figure also. So the weight supported here is 4,450. If the free end A of the string is pulled vertically downward with a constant acceleration A is equal to 18 meter per second, find the tension. Find the tension in the string. So here also what you have to find out, what is the tension T, which is actually in the string. And this is actually that particular string is wrapped around what? Wrapped around what? Wrapped around a pulley. So here we are neglecting the friction, whatever is the friction that is developed between the string and the pulley, that is totally neglected. I hope you understood the question. Clear? And this is the figure for that. The figure is given to you. I understood see the figure. Can you see the figure, all of you? Yeah, this is the pulley you see. There are two pulleys here you see. This particular weight What is the weight of this particular body? Weight of the body is 4,450. Clear? Newton. I have done a mistake in the question. It should not be kg. Clear? It is actually weight, actually 4,450 Newton. Okay. So the weight is 4,450 Newton. It is supported in a which plane? You can see the diagram. It is supported in a vertical plane. Okay. With the help of a string. These are the strings here you see. With the help of this string, there are two pulleys here you can see over here. Now, which is the free end? You can see here. This is the free end A. The question is given here. The free end A of the string is pulled vertically downward. In which direction you are pulling this? In the which direction? In the downward direction. Okay.
Downward.
With how much acceleration? With an acceleration A. A is also given to you.
Yes.
18 meter per second square. Okay. So you have to find out what is the tension T in the string. This is very easy question. Try to understand. Now here you can see the string is from this total string. Is it the same string or different string? Please see the pen. The string which is going here in this direction, is it the same string or a different string?
Same thing.
See, the string is totally same or not?
Yes, sir.
So as the string is totally same, now my question is, in a string which force will be there? Tensile force will be
And
there.
then
And
And
the
tensile force, how is away from the body or not? Now as the string is same, these all forces are a tensile force. Do you have any doubt? You can see. Because the string is same, the tensile force in all the strings is T or not? Yes or no?
yes, sir.
Yeah.
Yes.
Now, yeah, when you're pulling this string in downward direction, what will happen to this weight? Try to imagine. When you're pulling this string in downward direction, what will happen to this weight? Very simple. What will happen to the weight?
It will move upward.
moving
Yes,
upward.
the weight will move in which direction? Upward direction. Okay. Now, with what acceleration you are pulling it in downward direction?
1.8 meter per second.
Yes, that is A or not? 18 meter per second, let us put later on. It is A or not? You are pulling with an acceleration A. Now, my question is, when you are pulling with an acceleration A, the weight will go with what acceleration in the upward direction? Can anyone say?
Minus A.
Hmm. Again, I'm
Minus
asking.
a
Okay. You forget about all these things. Now, let me draw one more diagram here. I hope you can see, all of you, this particular diagram. I should have this. I should have done this type of problem first. Then you would have understood. Here, how many pulleys are there? All of you can see the diagram which I am drawing.
so one pulley
One
is
pulley.
here.
Weight is acting in which direction? Vertically downward direction. Clear? Suppose you are pulling this in downward direction at point A. With how much acceleration? With an acceleration A, suppose if you are pulling, this body also will move in which direction? Very simple thing. When yes, it will move in upward direction or not? With how much acceleration? I am asking. Arey, with same na? Arey, assume that you are sitting here, and you're sitting here, okay, and the rope is going through a pulley, and one of your friend is holding point A, and he is pulling you in downward direction with an acceleration A. So you're going in upward direction with what acceleration? With same acceleration or not?
Yes.
Yes, sir.
Same acceleration. It's not minus a.
Yes,
Minus
sir.
a, how it will be there? Minus a is when there is a surface is there. When you are applying the brakes, then all those retardation and the thing will come to you. Picture. When you are firing a gun, the bullet is going in the forward direction. The gun is recoiling back in the backward direction or not? In that case, negative acceleration will be there. Clear? But here there is no contact surface. So when you are pulling this particular body with an acceleration a, so the body will accelerate in upward direction with an acceleration a only. Did you understand? If you have understood this, now you say me, if you are pulling this body with an acceleration a, this body will go with what acceleration in the upward direction? Okay. Let me give you one more.
Same as
Okay, one more thing I'll give you. Suppose, can you see this distance here, all of you? Suppose you are pulling this down in downward direction. Suppose when you are pulling, assume that you are pulling 10 meters downward. The string of 10 meters you are pulling in downward direction. How many meters?
10
How many?
meter.
10 meters. This example I am saying, concept I am making you understand. This is 10 meters, you assume. Can you see my finger? This is 10 meters. This 10 meters I am pulling in downward direction. When I am pulling in downward direction, now these two strings you can see, these two strings also will go to the other side or not? 10 meters. Are yes or no?
Yes, sir. Yes, sir.
These two strings
Yes,
also will
sir.
go in the upward direction or not? Now here you can
Yes,
see
sir.
above this pulley, how many strings are there?
Two
Above this
speed.
pulley, two strings are there.
Two string.
Now when you are pulling 10 meters, these two strings will be 5 meter each in the upward direction or not?
Yes, sir.
Yes or no?
Yes, sir.
If you are pulling 20 meter to this, so this will be 10 each or not? If you are pulling 50 meter, this will be 25 meter, this will be 25 meter going in upward direction. When this string will go upward, then only the body will go upward or not?
Yes, sir.
So whatever you are pulling, that becomes half here. So if it is accelerating with an acceleration a, so acceleration also will become a by 2.
Two.
Understood?
Yes, sir.
Now this is very important problem also. If this is, you see, in this kind of problem, because there is a single pulley, when you are pulling with acceleration a, then this also will go with an acceleration a. But in this case, there are two pulleys are involved here. As said by the concept, if you are pulling with an acceleration a here, this particular body of weight W, which is 4450 Newton, will go in an upward direction with half of the acceleration. Okay. Now the problem becomes easier. Clear? So the body is going in which direction? The body is going in which direction? Upward direction. Okay. So you apply equation of motion. Can anyone say what is equation of motion? Summation of F is equal to
Summation of F is equal to
W by G
W by G
By G.
into acceleration.
into acceleration. Okay. So now let us substitute one by one. So this weight is going in which direction? In upward direction. So
Upward.
yeah, which force is responsible for the movement of the body? Anyone? So as this is going in upward direction, these two are vertical forces or not? We are not considering this force. These two. Can you see here? So T plus T is how much? It is going in upward direction. So it will be 2T minus W. Any doubts? That is the net force which is responsible for the motion of the body. Any doubts? Is this clear?
Is that
So in this case, it will be t minus w. In this case, it will be 2t minus w equal to w by g into, with how much acceleration it is moving?
18 meter per
A by 2 or not? Here, this body.
A by
Is this clear? Now let us substitute 1 by 1. So 2t is equal to, clear? I am taking w to the other side, it becomes positive. So w plus w by 2g into a. So 2t is equal to w taking common 1 plus a by 2g. Okay. So how much is w? 4450 into 1 plus a by 2g. I have not written a. Let us find a here. Again, same method. Clear? Sorry, sir. A is given to you. How much a is?
18 meter per second.
Yeah. So let us solve this. Can anyone say the answer? 4450 into 1 plus 18 by 2 into 9.81. What is the answer? Yes, what is the answer? So I am doing it here in the side. 2t is equal to,
T is equal to 6307.56.
do it again. 18 divided by 2 into 9.81 plus 1. This is 1.91 into 4450. So how much you got? 2t is equal to, can you see there? 8532.57 divided by 2. So what is the answer finally? 42.
4265.325.
Yeah.
65.
65 is also correct. Here I have taken the total value, that is why I am getting 4266. Okay. Yes.
4265.325.
Yeah, that is also correct. So 2t is equal to this much value, t is equal to this much. You can verify it. Okay. So I hope you understood this problem, all of you.
Yes, sir.
Yes, sir.